Hello students. Today we're going to look at section 7.3, which is solving systems of equations by elimination. This is the third process that we're going to learn on how to solve systems of equations. You'll remember that the solution to a system of equations is the point that satisfies all of the equations in the system. And today we're going to look at how we can eliminate one of the variables in the system in order to solve for the other one, and then use substitution to solve for the second variable. So let's look at our example. Our example is 2x plus 3y equals 11 and negative 2x plus 5y equals 13. In the elimination process, step 1 is to add or subtract the equations to eliminate one variable. Now, if we look at the two equations, what can I do to these two equations to eliminate one? Well, I know that if I add 2x and negative 2x, I get 0. So that's why I chose to add these two equations. When I do that, 2x plus negative 2x is 0, so I don't even write that down. And then 3y plus 5y is 8y, and 11 plus 13 is 24. So I just added those two equations together and ended up with 8y equals 24. Step 2 is to solve the resulting equation for the remaining variable. So if I know 8y equals 24, then I divide both sides by 8 and I get y equals 3. So now I've found half of my solution in that y equals 3. So now you've guessed it, in step 3, I'm going to take that y equals 3 and plug it into either equation. It does not matter which one. You plug it into one of the equations and then you solve for x. And I did it for both of them by plugging in 3 for y and substituting 3 for y in the second equation. And I solved both equations and my solution was the same, which it should be. So x equals 1. So the solution to this system is 1, 3, because x is 1 and y equals 3. And then I verify that, and I can verify that by plugging it in, and we'll do that right now. And I need you to write this down as well. So the first equation, 2 times 1 plus 3 times 3 equals 11. Does 2 plus 9 equal 11? Yes. And then the second equation, negative 2 times 1 plus 5 times 3 equals 13. Does negative 2 plus 15 equal 13? Yes. It works in both equations, so that is the solution to my system of equations. Now let's do a couple of examples together, just so that we make sure that you understand what's going on. Okay, so we're going to do this first one, 4x plus 3y equals 2, and 5x plus 3y equals negative 2. So I'm going to look for the variable that has exactly the same coefficient, and that would be y. They both have positive 3 as a coefficient. So what do I need to do to those equations in order to eliminate that y? Well, because they're both positive, then I'm going to have to subtract the equations. So I'm going to put a line and a subtraction sign, and then I'm going to go through and subtract. 4x minus 5x is negative x. And 3y minus 3y is 0, so I'm not going to put anything. And 2, here's where it gets tricky, 2 minus negative 2 equals 4. Again, 2 minus negative 2, minus a negative is the same as plus positive, so that equals 4. If negative x equals 4, then x equals negative 4. So now that I know that x equals negative 4, I'm going to choose one of those equations to plug that to substitute in that negative 4 for x and solve for y. I'm just going to pick the top one because it's there. So 4 times negative 4 plus 3y equals 2. Negative 16 plus 3y equals 2. Add 16 to both sides. And that would be 3y equals 18. Divide both sides by 3, so y equals 6. So my solution is negative 4, 6. And remember, I have to put them in parentheses. And to verify that, negative 4 times 4 is negative 16. 3 times 6 is 24. Sorry, 3 times 6 is 18. So negative 16 plus 18 does equal 2. So we get works for that one. And now for this one, 5 times negative 4 is negative 20 plus 18 is negative 2. So it works for both of those. So I'm going to slide on over here to the third problem there. 8x minus 4y equals negative 4, and 4y equals 3x plus 14. Well, just looking at those, I know that y has the same coefficient 4, but y and x aren't on the same side of the equal sign for both equations. So I've got to do some adjusting first. Before I can eliminate anything, I have to make sure that x and y are on the same side. So I'm going to adjust the bottom equation, and I'm going to bring the 3x to the other side. So that's going to make it negative 3x plus 4y equals 14. All I did was bring the 3x to the other side to make it negative. Everything else was the same. Now I can eliminate those y's by adding, because one's negative and one is positive. So I'm going to add those two equations. Here's where it can get a little tricky, so just you have to pay very close attention to your signs. 8x plus negative 3x equals 5x. And we know the 4's are canceling out. And negative 4 plus 14 equals 10. And then x equals 2. Now I'm going to take that 2 and substitute it in either of the equations to find y. Well, I'm going to go back to the original equation because it's already solved for 4y over there. So we're going to do 4y equals 3 times 2 plus 14. So 4y equals 20, which means y equals 5. So my solution is 2, 5. And if I plug those back in, 8 times 2 is 16, minus 4 times 5 is 20. 16 minus 20 is negative 4. And then 4y equals 3x plus 4. If 4 times y is 20 equals 6 plus 14, and 14 plus 6 is 20, so it works for both. And the last example that we're going to do together is 3x minus y equals negative 9. 3x plus 5y equals negative 15. So I look and see, it looks like I could eliminate the x's because they both have the same coefficient. So I would need to subtract them. So I'm going to subtract those two equations. 3x minus 3x is 0. And here's where it gets tricky. Negative y minus 5y is negative 6y. And negative 9 minus negative 15. So negative 9 plus 15 equals 6. So I divide both sides by negative 6, so y equals negative 1. Now that I know y, I can substitute back into one of those equations, and I can solve for x. I'm going to use the top equation. So 3x minus negative 1 equals negative 9. 3x plus 1 equals negative 9, because you'll remember minus and negative is the same as plus. So 3x equals negative 10. Don't freak out here. Divide both sides by 3, and I have an improper fraction that I cannot simplify, so I'm going to leave it as an improper fraction. So x equals negative 10 thirds. So my solution is negative 10 thirds, comma, negative 1. Yes, it's okay to get improper fractions. Don't worry about that. You don't need to change it to anything. You can leave it as the improper fraction. What I would like for you to do tonight for your practice is to solve 2 of the remaining 3. It doesn't matter which 2, you pick which 2. Top middle, or bottom left. Once you have solved 2 of them, if you're bold enough, you can go ahead and solve 3. Take a picture of your notes page and turn it in using the turn in button in Edmodo so that I can get it and make sure that you understand.